Hello,
Hello, sir.
how are you?
Fine, sir.
In that from last class,
No, sir.
so last class I defined you all different expansion relation and how it will depend or how temperature will affect density of a particular substance. Now on this basis, let me define you one more concept. From the above part, we can say on increasing temperature, volume will increase and consequently density of substance will decrease. But there is exception in case of water at a particular range of temperature, which is called anomalous behavior of water. This is volume versus temperature, and this is corresponding density versus temperature. Let's say this is 4 degrees Celsius. So from 0 degrees Celsius to 4 degrees Celsius, volume will decrease and density will increase. Within this particular range of temperature, on increasing temperature, volume will decrease and consequently density will increase. So graph will be like this. And for this, it will be like this. That's why water having maximum density at 4 degrees Celsius. Above 4 degrees Celsius, on increasing temperature, volume will increase and consequently density will decrease. So it will act like normal different body above this particular temperature. So only within the range of 0 degree to 4 degrees Celsius, it behaves different as compared to the rest of the body. That's why it's anomalous behavior. Is it clear?
Yes, sir.
This behavior of water provides a facility or for the existence of aquatic life. Suppose the temperature of outside of this water body becomes less than 0 degrees Celsius. So it will start freezing. So formation of ice will take from the surface of water like this. So ice will form initially at this point. And further, this ice layer will act as shield to its innermost liquid. So it acts as insulating surface to provide this particular liquid not interacted with the temperature of outside. So this will remain to be at 4 degrees Celsius, whatever the temperature of surrounding would be. Is it clear?
Yes, sir.
This helps aquatic life to survive within this particular movable liquid. Any doubt?
No, sir.
Okay, just draw this.
I know. Done, sir.
Okay. Next, may define expansion of liquid in a vessel. Suppose there is a vessel like this, which is placed over any burner. Let's say level of liquid initially is up to this point, A. So you will be asked, what will happen to the level of liquid on heating initially? We are considering before its evaporation. Will the level of liquid increase or decrease or remain same?
It will remain same, sir.
By we are heating it, so it must expand.
Oh, so it will increase.
No, let me define it. Just think, on giving heat, which one will receive heat first, the vessel or the liquid?
Vessel.
Vessel. So which will expand first, liquid or vessel?
Vessel.
So if vessel expand from its normal volume, so level of liquid will increase or decrease?
Decrease.
Good. So initially, since heat is being absorbed first by vessel, so its volume would increase. So level of liquid should decrease initially. Then further, when it transfer heat to liquid,
Evaporation.
it will expand, and then level of liquid may increase to some new point. So initially, this level may decrease to this point due to expansion of vessel, and further, it may reach to this point due to its own expansion. So you'll say, since heat is being absorbed first by vessel, so it will expand first. So level of liquid decreases. Then due to its own heating. Level of liquid will increase. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Okay, so if you have to calculate these different measurement, so B to C must equals to A to B plus A to C. B to C is in this part a real expansion of liquid. A to B we have expansion of vessel. And A to C is apparent expansion. You'll observe. So in this part, a liquid would expand at same rate in all different vessels. So you'll say a real expansion of liquid in all different vessels will be same. Just write it down.
Done, sir.
So this is all about the expansion part. Next, we start with new term that is called calorimetry. So first, what do you mean by calorimetry? So you will say the study of exchange of heat between system or surrounding, which result in change of state or change of temperature, is called calorimetry. So it is the study of exchange of heat between different body or system, which may result in change in temperature or state. So depending upon conservation of need, conservation of energy, may define principle of calorimetry. It is based on conservation of energy. It says heat lost by one body must equals to heat gained by the other if there is no loss of energy into surrounding. So you'll say if there is no loss of heat into surrounding, so heat lost by one body must equals to heat gained by other. Now, this heat may change the temperature of that particular body or may change the state of that particular body. So depending upon this may define heat into two parts. First, heat, which can cause to change the temperature of body, and second, heat, which can causes to change the state of body. So in first part, causes a change in temperature, we may define three different terms. First is called heat capacity. Second is called specific heat capacity. Third is molar specific heat capacity. Similarly, heat which causes a change in state, first is called latent heat of fusion to change solid into liquid. And similarly, the next is latent heat of vaporization, that is from liquid to vapor. First, write it down, then I'm defining these different terms individually. Harsh, any doubt?
No, sir.
Okay.
Done, sir.
So first term related to this part is heat capacity. It is the amount of heat required to change the temperature of any substance by 1 degree Celsius or 1 Kelvin at normal atmospheric pressure. So it is the amount of heat is required to change the temperature of substance by 1 Kelvin or 1 degree Celsius at normal atmospheric pressure. So Q equals to S times delta T. So this S is called heat capacity. So its unit is joule per Kelvin. But if there is some specific mass or fixed amount of that particular substance, that is called specific heat capacity. So it is the amount of heat is required to change the temperature of 1 kg substance. In this part, there is a fixed mass or the fixed amount of that particular substance. Substance by 1 degree Celsius or 1 Kelvin at normal atmospheric pressure. That is called specific heat. So Q equals to mass of substance times S times delta T. So this small s is called a specific heat capacity or constant. So its SI unit will be, SI unit is joule per kg per Kelvin. Now you have to remember some of fixed values related to some specific quantity. In case of ice and vapor, specific heat constant will be same, and that is about 0.5 calorie per gram per Kelvin. How to convert calorie? 1 calorie is equals to 4.186 joule, or you may write it as 4.2 joule. Harsh, any doubt?
No, sir.
Similarly, in case of water, it is 1 calorie per gram per Kelvin. Next, if substance is or if the amount of substance is being measured in terms of number of moles, that is in case of gas, that is called molar specific heat. Molar specific heat capacity or constant. So it will be the amount of heat is required to change the temperature of 1 mole gas by 1 Kelvin or 1 degree centigrade at given condition. Since molar specific heat will have different value related to a different process, like for isobaric, isothermal, adiabatic, isobaric, it will have different value. So Q equals to number of moles times specific heat times change in temperature. So this C is called molar specific heat capacity. So it's SI unit, joule per mole per Kelvin. So to change the temperature, we mainly have these three different heat. So what would be the relation between these terms? Let me define you. S equals to M times S equals to N times C. So this is the relation between these three terms. If heat is same, you may convert number of moles in terms of given mass by molar mass. Harsh, any doubt?
No, sir.
Okay, just write it down.
Done so.
So these are different heat which will be responsible to change the temperature of substance. Next is latent heat. So first one is
Latent heat of fusion.
latent heat of fusion, that is conversion of ice into water at its melting point. So it will be
Solid.
the amount of heat is required to convert 1 kg solid, that is ice, into water, that is liquid, at its melting point and normal atmospheric pressure. So Q equals to mass of substance times latent fusion constant. So this L is called latent heat of fusion constant. In case of ice, it is equals to 80 calorie per gram. Next is to convert liquid into vapor.
Latent heat of vaporization.
Good. So it will be
The amount of
latent heat of vaporization.
the amount of heat is required to convert 1 kg solid, 1 kg solid
into 1 kg liquid
into vapors.
into vapor
At its boiling point.
Good. Boiling point and normal atmospheric
pressure.
So Q equals to mass of substance times latent vaporization constant. So this L is called latent heat
of vaporization constant.
So latent vaporization in case of vapor is equals to 540 calorie per gram. Okay, just write it down. Then I'm
Yes.
defining how to solve.
Done, sir. Sir,
Yes.
how many topics are left to finish this chapter?
After this, one more thing, that is heat conduction, and the last part is radiation.
Okay, like after that, we'll do the thermodynamics.
Yeah. In which chapter you are in school?
Sir, like we have started thermodynamics.
Okay. Now, for this particular process, first, let me define a graph related to this entire part. On the basis of graph, you'll be asked some different questions. This is variation of temperature versus heat in case of water, ice, and vapor. Let's say this is temperature and this is amount of heat being supplied to it. Initially, suppose ice is at some low temperature, minus 10 degrees Celsius, minus 20 degrees Celsius. Let's say at this point, ice, which is at minus 10 degrees Celsius. So if you supply heat to this particular ice, so it will tend to increase its temperature. So from this point to this point, it will remain ice. This amount of heat being supplied to it is responsible to change its temperature, that is called specific heat. Further, at this point, if you supply heat, then its state will change from ice
to liquid
to water till this point. So at this point, there is no change in temperature.
So
since, yes,
the graph should go up, right?
No. At this point, the amount of heat being supplied to ice is utilized in changing or breaking down of bond of ice so that it may convert into water. Okay, so there will be no rise or fall in temperature. That's why it is called latent heat, hidden heat, since there is no significant change in temperature on supply of heat to this particular substance. Further, at this point, ice is at 0 degrees Celsius. So if you start heating further, temperature of water will start rising from 0 degrees Celsius to maximum 100 degrees Celsius. So this is again amount of heat supplied to water to raise its temperature from 0 degrees Celsius to 100 degrees Celsius. So it will be specific heat. Heat required to change temperature. Okay.
Yes, sir.
Further, at this point, if you supply heat, its state will change from water to
gas, vapor.
Until complete conversion, there will be no change in its temperature as the amount of heat supplied will be utilized in breaking down of bond. So this is called latent heat.
Or vaporization.
Further, if you supply heat, graph, or it will tend to increase its temperature at some higher. So it will be termed as specific heat. So we have three different straight lines in this entire term. So we may define its inclination related to this part. Let's say this is theta 1 and this is theta 2 and this is theta 3. So first question will be how these theta will be related with one another. So to define this theta, let me explain you this particular graph. In this graph, we have y-axis as temperature and x-axis as heat. And for all three different straight line, this is defining nothing but specific heat. So we may write as for a specific heat, dq equals to ms times dt. dq is heat supplied to the system, m is mass of the substance, and s is specific heat. dt is change in temperature. So in this part, y-axis is dt and x-axis is dq. So dt must be in numerator and dq must be in denominator. So just rearrange it. So dt divided by dq
DQ.
equals to 1 by m into s. So this particular quantity is defining nothing but perpendicular by base related to this particular graph. So it will be termed as slope of T versus Q graph. And it is depending over S, that is specific heat constant of substance. So greater the value of specific heat of substance, it will have smaller slope. Is it clear?
Yes, sir.
So as I defined you above, for ice vapor, specific heat was 0.5, but in case of water, it is maximum, that is 1 calorie per gram per Kelvin. So we can say, since specific heat constant of ice is equals to specific heat constant for vapor,
Of vapor.
and these are smaller
There
as
are
compared to water.
water.
Therefore, since slope and specific heat is inversely proportional, so slope for ice is theta 1 and slope for vapor is theta 3 must be greater than slope for water. Is it clear?
Yes, sir. Sir,
Okay. Yes.
like we can also write like at each theta, like there's a change in state.
No. These theta
Like
are
we can't
defining.
write that, right?
Yeah. At the point of change state, there is no any angle inclined. There is no inclination to that particular line.
Okay.
So those are parallel to x-axis, at which there is no change in temperature. Slope will be 0 at that instant.
Okay.
Okay. Now, next question will be related to this curve. If you have water and vapor at same temperature, that is 100 degrees Celsius, which one will cause more severe burn, water or vapor? So from this graph, let me show you. Just draw vertical line
So it's
to
vapor,
this
right?
and just draw a vertical line to this. So from this graph, water is at this point, or heat of water is at this point, and heat contained in vapor is
So
this
vapor,
point.
right?
Yeah, good.
It's vapor.
So from this part, we can say, since vapor having more amount of heat as compared to water at same temperature, so vapor will cause more severe burn as compared to water at same temperature.
Yeah. Yeah, because this was a question in ninth grade. That's why.
Yeah. Similarly, in this case, in case of ice and water, you'll be asked which one will cause or which one will better in cooling, or which one will
Ice,
cause more effective in cooling, ice or water. So you'll say ice having
ice having low
more,
temperature. Yeah.
since water having more amount of heat energy as compared to
Okay.
ice,
Yeah. Heat energy,
or
yes. An x-axis.
just in opposite, you can say ice having more cold energy as compared to water at same temperature, that it will act as good cooling
Cooling
agent.
agent. Okay.
So first is At same temperature, ice and water. Since ice having more cold energy
Then water.
as compared to water.
It will be a better
So,
cooling agent.
so it will be more effective in cooling.
Yes.
Similarly, in case of at same
Same
temperature,
temperature, 100 degrees Celsius.
100 degrees Celsius, that is
Vapor
water and vapor. Vapor having
more more hot,
heat energy,
more heat energy. Yes, more heat energy as compared to water. It will be
so it can cause
severe burns.
severe burn. And similarly, there will be a question why there is no change in temperature during change of state. So you'll say the amount of heat supplied during change of state is utilized in breaking down of bond.
Bonds.
So there will be no significant change in temperature.
Yes.
So during
Change of state, the heat energy
heat supplied
is used in breaking down of bonds.
to the system is utilized in breaking of bond. Hence, there is no
change of temperature.
In temperature.
Yeah.
I'll just write it down these down.
Yes, sir.
Just draw this particular graph.
Done, sir.
Now, related to this part, there will be question. Find amount of heat is required to change the temperature of 10-gram ice at minus 10 degrees Celsius to plus 10 degrees Celsius. So for any different question, first try to draw graph for its variation, temperature versus heat. So in this part, let's say this is T versus Q. So ice initially is at minus 10 degrees Celsius. So it will be at this point. So if you supply heat to this, it may convert its temperature to reach at this point. So let's say this is Q1, heat supplied to it to change temperature from minus 10 degrees Celsius to reach 0 degrees Celsius. Further, on supplying heat, it will change its state from this point to this point, that is from ice to
To
water.
liquid.
So it will be Q2, that is latent heat. And further on heating, it will
10
raise
degrees
its
Celsius.
temperature to 10 degrees
10
Celsius,
degrees Celsius.
that is Q3. So it will be plus 10 degrees Celsius. So we have to calculate Q1, Q2, and Q3 and just add them all. Is it clear?
Yes, sir.
So in first part, Q1, which is specific heat, so mass of ice, specific heat constant of ice, and change in temperature 0 minus 10, that will be 10.
10.
In second part, that is latent heat of conversion ice into water, so it will be fusion. So mass of ice to be
Mass of
melted
ice.
and latent fusion constant. And third part, this entire ice get melted into
Liquid.
water, but mass will remain same.
Same.
Now it will become water, so it's
Water.
specific heat of water, and change its temperature from 0 to 10.
10.
Okay, just put all the values and simplify it.
So we are adding all the values, right?
Yeah.
So what's the answer?
I think it will be around 950.
Oh.
Should I solve?
So done.
You're solved.
Yeah, I'm just doing it. Like I'm in the ending stages of it.
Okay. So you got the same answer.
No, I just asked you, like I'm close to that, but I'm doing it still.
Okay.
Yes.
Your answer will be like this.
Yes, sir. Sir, is 1 minute, sir. I'm still.
Harsh, you got this?
Yes, sir.
Okay. Now let me define you another question. Find amount of heat released on condensation of vapor at 100 degrees Celsius to water at 50 degrees Celsius. In this part, vapor is at this point. So on cooling down, it will generate amount of heat which is equals to latent heat of vaporization. And further, to decrease its temperature to 50 degrees Celsius, it will reach to this point. So let's say this is Q1 and this is Q2. So Q1 will be mass of vapor. So find amount of heat released on condensation of 1 gram vapor at 100 degrees Celsius to water at 50 degrees Celsius. So mass of vapor times latent of vaporization constant, and Q2 is mass of vapor. Now it has converted into water times specific heat of
Specific
water
constant.
and change in temperature, that is 100
100.
minus 50.
50.
Just solve these two terms and just add it.
Yes, sir. So what's the answer? What's this?
Just 1 minute. It will be around 590, I think.
590, sir.
Yeah.
I'm getting 542.
No, just let me check. Net amount of heat will be take MV as common. Latent of vaporization plus specific capacity of water multiplied by 50.
50.
So mass of vapor is 1. Latent of vaporization constant is 540 plus
1. Yeah.
1 into 50.
Yeah, 1 into 50, 50, 50.
So it will be 540 plus 50, that will 590.
Okay. Oh, yes, sir. Sir, I didn't add 50.
Okay. Done?
Yes, sir, done.
Okay. Now there will be some question in terms of water equivalent. So let me define you what do you mean by water equivalent. Suppose you have heat supplied in case of water, that is mass of water, specific capacity of water, and change in temperature is delta T. Similarly, same amount of heat is supplied to some other substance. So mass of substance, specific capacity of substance, change in temperature. So if heat in both these two processes same, so we can equate them. Mass of water, specific capacity of water, change in temperature equals to mass of substance, specific capacity of substance, change in temperature. This term and this term is cancelled out.
Cancelled, yeah.
So if we calculate mass of water related to this part, so this quantity is called water equivalent.
Okay.
So for water equivalent, just water equivalent multiplied by specific capacity of water will equals to mass of substance times specific capacity of substance. So instead of giving you these two values, that is mass of substance and specific capacity of that substance, they will give you just the value of water equivalent. Okay?
Okay.
So just multiply water equivalent times specific capacity of water. These two terms will be equal to mass times specific capacity related to that particular substance. Okay? Okay, just write it down.
Done, sir.
Okay. Find amount of heat is required to change the temperature of calorimeter by 20 degrees Celsius if its water equivalent is zero point 0.8 gram. Just use the above concept and try to find.
Okay, so sir,
Yes,
what's the answer?
how much you get?
Sir, I'm still confused. Can you solve it?
Okay. According to the above relation, we may write Q equals to mass of calorimeter times the specific capacity of calorimeter times change in temperature. Now, this particular term in terms of water equivalent will be equals to water equivalent multiplied by
Multiplied by
specific capacity of water
water
times
and
change in temperature.
yes,
So what we have in case of water equivalent, in place of water equivalent, it is
0,
0.8
0.8,
multiplied by specific capacity of water, 1,
1,
and change in temperature is,
20.
so 8 into 2, it will be 16 calorie. Yes, any doubt?
No, sir.
Okay.
None, sir.
Okay, so this is all about calorimetry and its various other relationship. Next, we start with heat transfer. Mainly have three different ways of transferring heat. First is
Conduction.
conduction. Second
Solids
is
to solids. Convention.
convection.
Right.
And third
Convection.
is
Yeah.
radiation.
Radiation.
So first is about conduction.
Solid to solid.
So this is only for solid,
Yes.
only for fluid,
For
and
fluid.
the radiation is even through vacuum.
Gas.
It can travel even through vacuum or air.
Vacuum.
So first is conduction. Suppose you have any solid in which particles are arranged at this point. So it will have some vibrational amplitude up to some specific distance. So if you increase the temperature of this particular end, so on increasing temperature, its vibrational energy will increase. So it will tend to vibrate to some larger distance, during which it may collide with its neighboring particle. And on collision, they may transfer some of their energy. This process of transfer of energy will take place from one end till the other end, due to which or by which it may transfer energy or heat energy from one end to other end. This is called conduction. Is it clear?
Yes, sir.
So you will say in this part, on supplying heat or increasing temperature of one end, vibrational thermal kinetic energy of particle increases. So it will tend to vibrate to longer distance, during which they collide with neighboring particle and transfer their energy. This process will continue till energy reaches to other end. Is it clear?
Yes, sir.
Just write it down.
Done, sir. Sir.
Just 1 minute.
Okay, sir.
Harsh,
Yes,
in
sir.
doubt?
No, sir.
Okay, to define this particular conduction, let me define you with the help of electricity. You must have learned in class 10th as well. So, electric current and heat current. Suppose I have a rod having length L from this end to this end. Area of cross section A. Similarly, in this part, length of this rod is L. Area of cross section is this. So tell me the responsible factor to flow current through a particular conductor. Which agency will cause to flow current or electric charges through any conductor? Harsh, do you know?
Yes, sir.
Which factor will be responsible to flow current through any conductor?
Factor. Which factor?
Any external agency responsible to flow current or charge through any conductor?
I don't remember, sir.
You must have used DC source in the form of battery. Okay.
Okay.
Suppose you have a battery and you have connected it with any electrical bulb of similar range.
Yes, sir.
So it will tend to glow.
Yes.
Okay.
Yeah.
So what you can say about battery will provide to that particular electric bulb?
Current.
Current?
No. What will battery provide to the electric bulb?
Or to this particular entire circuit?
Energy, sir.
Every conductor,
Yeah.
if you have to flow electric current through it, you must have some potential difference across it. So battery simply provides potential difference across it. And due to that potential difference, it will tend to move charge or electron through it. Is it clear?
Okay. Yes, sir.
So first responsive factor to generate electricity through it should be potential
Potential
difference.
difference. Sir, how many factors are there?
Just one.
This one.
So potential difference, that is higher potential minus lower potential. Suppose you have water in two different tanks and you have to flow water from one of the tank to the other. So what will you do? You will change simply the level of two tanks like this.
Yeah. Yeah. So the
So
water can flow.
Water will flow from which state to which state?
From
Lower.
a level of higher concentration to lower concentration.
Good. That means higher level will have higher gravitational potential energy and lower level will have lower gravitational potential energy.
Yes.
Similarly, in this part, if you have any conductor, so it's both end will be at same potential. So there will be no flow of charge in any one direction. So
Okay.
you must have to change the potential difference across it. So
Okay.
let's say V1 is at a higher potential and V2
And
is
V2
at
is at
lower.
lower potential.
So due to this potential difference, there will be some flow of electricity or electric charge through it. Similarly, in case of
in heat current also it's same, right?
So to flow heat through any conductor, it must have some temperature difference.
Oh yeah, temperature difference. Yes, like from the level of higher temperature to lower temperature.
Good. So let's say T1 is at higher temperature and T2 is at lower temperature.
Lower temperature.
So from both these two terms, we can say as in electricity, potential difference will be responsible to flow electric current through it. Similarly, in case of heat, temperature difference will be responsible to flow it. Is it clear?
Yes, sir.
Okay. Next, there will be some opposition to the flow of electric current through any particular conductor. That opposition is called resistance. So let me define you first. Resistance offered by any conductor. You must have learned about it in class 10th as well. Various factors on which resistance of a conductor may depend upon, just as area, length, temperature. So resistance will be equals to rho L by A, where rho is called resistivity. We may define another term, that is sigma, which is called conductivity.
Conductivity.
So these two are just reciprocal of one another, resistivity and conductivity, like this. Similarly, in case of heat, there will be some opposition to it, which may be defined as thermal resistance. Thermal
resistance,
which is equals to L by A. In place of rho, we may write as 1 by sigma, but in this term, it is represented by K. So K in this term is called thermal conductivity.
K is the constant of thermal conductivity.
Similar to sigma. Okay?
Okay. Yes, sir.
Now you must have learned about Ohm's law in class 10th. Before that, let me explain you one more thing. In case of electric current, electric word defines for electric charges and current means flow of it through any conductor per unit time. So electric current means a rate of flow of electric charge denoted by I, which is equals to Q by T. Q is charge flowing per unit time.
And T is time
Similarly,
taken.
yeah. So this is
Electric current.
similar in case of heat. We may define heat current, that heat flowing through any conductor per unit time, that is called heat current,
Heat
denoted by H, which is again equals to Q by T,
Q by
where
T.
Q is heat flowing per unit time.
Yes,
Is
sir.
it clear?
Yes, sir.
Now just tell me about Ohm's law. You must have learned about it in class 10th as well. It states at constant temperature, keeping other physical parameter of conductor remains constant. The more you
Constant.
supply potential difference through a particular substance, the more amount of current will flow through it.
Current will pass. Yeah.
It means potential difference is directly proportional to current flowing through it.
Current flowing. Yeah.
So according to this, we may write V is equals to I into R. So I must equals to voltage divided by resistance.
Yes.
I is nothing but charge flowing per unit time, which is equals to potential difference by resistance. Resistance is rho L by A. In terms of sigma, it will be sigma A delta V divided by L. Similarly, we may define in terms of heat current as well. According to Ohm's law, heat current will be equals to potential difference divided by resistance offered. Heat current is flow of heat per unit time, which is equals to Ka delta T divided by L. So using this concept, it will be more easier for you to remember these two concepts. Is it clear?
Yes, sir.
Harsh, any doubt?
Yes, sir. No, sir.
Okay, just write it down.
Yes, sir. Done, sir.
Okay. I have just derived this particular formula using the concept of electricity. You may derive this particular relation in some other way also. Let me define you. You will say heat flowing through any conductor is directly
proportional
to area, change in temperature, time, and inversely proportional to the length of conductor.
Yes, sir.
So using this, we may write Q proportional to area, proportional to change in temperature, and
time
divided by length. So removing this proportionality constant, we may write it K A delta T divided by L. Now move this T to left side. So it will be Q by T
is equal
which is
to
also called H K A delta T by L. So you'll get the same result as we have derived above. Okay?
Okay. Yes, sir.
Just write it down.
Yes, sir. Done, sir.
Any doubt up to this part?
No, sir.
Okay, so let's stop here for today. In next class, we'll start with this part and I will define you combination. Okay?
Okay, sir.
Okay then. Thank you.